In this video, we're going to talk about solving right triangles. Um, Previously, we've learned about two acute angles and a right angle, acute right triangles, and we talked about something really important, SOHCAHTOA. So that sine of some angle theta, which is acute, is going to be opposite over hypotenuse. Cosine of an acute angle in a right triangle is adjacent over hypotenuse. And then tangent is going to be opposite over adjacent. So we've got that stored. We know it. We understand it. We can use it. Now we're going to talk about solving right triangles. And what solve means is we're going to find all three lengths of the sides as well as all three angles. So three sides and three angles. We have an important note here. When we draw right triangles, we use the angles, we use capital letters to represent the angles. So notice I have capital A, capital B, capital C for those angles. And then the sides are labeled with lowercase letters, lowercase a, b, and c. One other piece to notice is that corresponding sides and angles are opposite each other. So I have C opposite C, A opposite A, and B opposite B. So we need to use this kind of organization because it just helps us when we're drawing pictures and, figuring out how to solve these triangles. All right, so here we have two pieces of information given. We know that little side A is 10.2. And we also know that little side C is 20.4. And of course, we're given that angle C is my right angle. So considering this, and considering we have a right triangle, I automatically know that 20.4 is going to be my hypotenuse. The challenge we're faced with here is we need to determine what these two angles, A and B, what these acute angle measurements are, as well as the length of side B. So we're always going to be given three pieces of information, either two sides and an angle, or two angles and a side, or three sides. And then we need to find three other pieces. So I'm looking for side B first, and you can do this in any order. It's just a matter of what you see. But my first step here is going to be side B. And since we're dealing with a right triangle, and we know two sides of a right triangle, we can use the Pythagorean theorem, which says the leg squared plus the leg squared equals the hypotenuse squared, or 10.2 squared plus b squared is 20.4 squared. B squared is 20.4 squared minus that 10.2 squared. And we determine that b squared is 312.12. B is plus or minus the square root of 312.12. B is 17.67, and that's approximately. The exact decimal is 17.66691,824. So we have an approximate value for B. We found one of our pieces. Now, because this is an approximate value, I'm going to try to avoid using it in future calculations. Or I could use my exact value. My exact value for B is the positive square root of 312.12. So that represents an exact value. But that's kind of an ugly number, so we don't want to deal with that. This number is, of course, rounded so that it's approximate. So my next step is I'm going to find an angle, either angle first. I'm going to choose to find angle A. So my second step would be to determine angle A. So angle A means we're considering this angle. Which two sides do we know in relation to angle A? We know 10.2 as well as the 20.4. 20.4, of course, is the hypotenuse. That means that 10.2 is opposite A. So if we're dealing with A having an opposite and a hypotenuse, which trig function does that mean we might use? And if we rewrite SOHCAHTOA, we see that sine deals with opposite and hypotenuse. So I would write here sine of A equals my opposite side, 10.2, divided by my hypotenuse, 20.4. Or rather, sine of A is 1/2. And because we have memorized some values, we know that that's going to occur where where A is equal to 30 degrees. However, if we were solving it algebraically, we would take that sine and move it over to the other side, and we'd say sine inverse of 1/2. If you type that into your calculator in degree mode, not radian mode, degree mode, you're going to get 30 degrees. So A is 30 degrees. And then, of course, we can go one step further. We'll find the measure of angle B. Because we know that two angles in this triangle, we know 90 and 30, and we know that the three angles inside of a triangle are going to sum to 180. I can say 180 minus 90 minus 30, and that's going to give me 60 degrees is equal to B. So I have found 1, 2, 3 missing pieces. I have solved the triangle. I now know all three angle measures as well as all three side lengths. And just as a note, if I wanted to find B and I wanted to use the two given sides, in that situation, 10.2 would be adjacent to B. And adjacent and hypotenuse, that would mean I would set this up. I would say cosine of B is 10.2 over 20.4. Rather, cosine B equals 1/2. And then B equals cosine inverse of 1/2, which gives us, again, 60 degrees for B. Cosine of 60 is 1/2, and we know that from the values we memorized from our previous section. So we could have done it that way as well. But once you know two angles, you can subtract them both from 180 to find that third missing angle. So that's how you solve a right triangle. It's all about breaking it up into different pieces, determining what you do and don't have, and then, in regard to the angle you're considering, which sides are relating to it. So always going back to SOHCAHTOA. And remember, opposite and adjacent, those change based off the angle that you're considering. So when you move angles, the opposite and adjacent side to that angle are different. All right, so in the next video, I'm going to do a couple application problems where we use these concepts in a real life setting.